Hello, and welcome to the LabVIEW IV COM demonstration. My name is Sean Shaw from National Instruments. IV drivers make it easy to programmatically command instruments from numerous vendors. There are two different architectures that IV technology supports, IV COM and IVC. National Instruments drivers are written utilizing the IVC architecture, but both IVC and IV COM architectures can be used with LabVIEW. This demonstration will illustrate just how easy it is to use IV COM drivers within LabVIEW. Now, in order to follow along with this demonstration, first download and install the Agilent 34401 IV COM driver, version 1.2.2.0 from October 2008, as well as at least IV Compliance Package 4.6. For assistance finding and installing the software, just refer to the IV Getting Started PDFs on the Resources page of the IV Foundation website. Today we will be building a VI to acquire a simple simulated voltage using our Agilent 34401A IV COM driver and LabVIEW. Here's a look at our finished code. Now let's start by creating a blank VI. Next, navigate to Connectivity, ActiveX, and Automation Open. From this palette, we can access ActiveX and COM objects, including all IV COM drivers installed on your system. Right-click on the upper left-hand corner Automation RefNum terminal, then navigate down and choose Select ActiveX Class, and then Browse. In the drop-down of the dialog that appears, select IV Agilent 34401 1.2 type library version 1.2. Then select the iAgilent 34401 object at the top of the listed objects. If the IV COM driver you want to use is not listed, download and install the driver and close and restart LabVIEW. The driver should now appear in the type library browser. When you're finished, click OK. Now we need to initialize the instrument. From the View menu, select Class Browser, or press Ctrl-Shift-B. The Class Browser allows you to invoke methods and set or get properties of ActiveX or COM objects, and we will use it repeatedly while building our demo. Alternatively, once we have a reference or refnum to the IV COM object, we also have the option to drop invoke or property nodes on the block diagram and simply pass along the object refnum. You may choose either of these methods, but to get us started, I will first show how to use the Class Browser. From the Object Library dropdown, select ActiveX, and then choose Select Type Libraries. From the options available, you're going to want to choose the IV Agilent 34401 1.2 type library version 1.2, and then click OK. Now the Class Browser is set to the correct object, and you should see methods and properties for the Agilent IV COM driver. Scroll down and select Initialize from the available methods, then click Create and drag the invoke node to the block diagram. Now we can set our resource ID for the instrument, which is available in Measurement and Automation Explorer. We can also set the ID query to false, reset to true, and our option string to simulate equals 1. We can also connect up the reference wires and our error wires. Go back to the Class Browser and under Properties, select DC Voltage. Then select the Configure method. Click Create and drag the invoke node to the block diagram. Next, create constants and enter values to set the resolution to 1 millivolts and the range to 1.5 volts. We also want to connect up the reference and error wires again. Then repeat this process to set a trigger delay to 0.01 seconds. Before I had mentioned an alternative way of calling methods and setting properties by passing along a reference to the IV COM object. LabVIEW refers to this reference as a refnum. Let's do that now. Drop a property node on the block diagram and connect the refnum terminals. Then right-click Property, browse to Select Property, and click Browse. From the available properties, First select Trigger, and then select Delay before clicking OK. Once we set this property so that it's writable, we can set the 0.01 second delay. We can repeat this process and select the read method with a 1000 millisecond timeout and the close method before displaying any possible errors. Now let's run the demo and test our code. For this particular simulated IV COM driver, the expected simulated voltage is 0 volts. I placed a default reading of 3.141592 or pi, so we would better notice our simulated reading. Now let's run our code. As expected, we received our simulated voltage reading. This concludes the IV COM demonstration for LabVIEW. I hope you've been able to see how easy it is to bring IV COM drivers into the LabVIEW environment. For additional information, including videos, tutorials, and more documentation, you can go to the Ivy Foundation website at www.ivfoundation.org. Thank you.